Welcome to Forge College. Today we are tackling the final Capstone project for raw transaction construction. Over the last few lessons, you've collected a highly specific set of tools. You've mapped out strict serialization rules, decoded inputs, constructed pristine outputs, and mapped out security scripts. But right now, you have a bowl of flour, a stick of butter, and a raw egg. Great ingredients, but definitely not a cake. To get a transaction the Bitcoin network will actually accept, you have to compile these isolated cryptographic pieces so they speak the network's native language. Your central goal for this lesson is to synthesize all your previous work into a single verifiable raw hexadecimal string. To pass this capstone, you must meet 3 strict acceptance criteria: build the hex, prove the math, and audit the security. Successfully combining these disparate elements from scratch provides the evidence that you've mastered how the Bitcoin network operates at the foundational byte level. Let's get to work. The first phase of our pipeline is hex assembly. We start by pulling in those unsigned inputs and outputs you created back in Lesson 3. Next, we organize these components according to the strict serialization rules we covered in Lesson 1, stacking them in the exact order the protocol demands. See how discrete blocks, inputs, outputs, headers, scripts slide together into one continuous hexadecimal string. Precision is everything. A misplaced varint, or formatting little-endian backwards, is like confidently tripping over your shoelaces. Properly aligned, this hex is ready for machine validation. But assembling the hex string is merely the first step. The true test of your construction is whether an automated script can read exactly what you just wrote without throwing a fatal error. Your first defense against those fatal errors is the round-trip serialization test. This serves as an uncompromising audit for your constructed hex. This flowchart maps the round trip. First, deserialize your new hex string into a parsed transaction object. Then, immediately reserialize it back into a hex string. If the bytes don't perfectly match, it flags an encoding or endianness error to fix. Once your hex survives the round trip, we transition to the second critical check, arithmetic verification. This is where we verify the fundamental fee equation. The total sum of your input amounts minus the total sum of your output amounts equals the transaction fee. Just remember the golden rule of Bitcoin arithmetic: no floating point math allowed. A fraction of a Satoshi does not exist. All calculations for this capstone must be documented using exact whole Satoshi integers to pass automated validation. Passing the round-trip decode and the integer mouth checks proves your transaction is structurally sound. That leaves only its security to be verified. The final phase of the capstone is auditing the transaction's security, which directly ties back to the concepts you analyzed in the previous lesson. Looking at this parsed code, extract the exact signature bytes and SIGHASH flags, highlighted here. Vague statements are unacceptable. Address vulnerabilities by citing these exact bytes. For instance, to mitigate signature malleability, point to the specific SIGHASH flag to justify your strategy. A valid raw transaction requires a mathematically balanced equation, but the work only concludes when the script is demonstrably secure at the microscopic byte level. If your math checks out, your bytes match, and your security is sound, congratulations! Completing this capstone means you have deterministically built, verified, and audited an authoritative Bitcoin transaction from scratch. This structurally perfect raw transaction is now entirely ready to interact with the broader Bitcoin network. In the next module, What is Bitcoin mining and why it matters, we will look at how miners take these raw transactions and package them into blocks based on the exact fee structures you just calculated. Be sure to save your code snippets and hex strings, as you'll need to reference them to fully understand how miners view your work. Thank you for learning with Forge College. To dive deeper into this subject and explore other Web3 fundamentals, visit us at forge.college. Happy building!